All right, let's talk about LangChain's secret weapon. It's the one thing that makes a chatbot feel like it's actually listening to you. I'm talking about conversational memory. This is what separates a smart AI from, well, just a bot. Let's dive in.
I mean, we've all been there, right? You're talking to a chatbot, and on the left, you see what happens. It forgets what you said just one message ago. It's so frustrating. But then look at the right. The conversation just flows. That ability to remember, it isn't just a cool feature. It's absolutely essential. So how do we get there?
Well, that brings us to what I call the goldfish problem. And it's the biggest hurdle we have to jump when we're building these things.
You see, at their core, large language models are stateless. What that means is they have zero built-in memory of anything you've ever said to them. Every single time you hit send, it's like you're talking to it for the very first time. That's the digital goldfish. Without a little help, its memory is wiped clean every single time.
But don't worry, because this is where LangChain swoops in with a really smart solution. Let's take a look at how it gives our digital goldfish a long-term memory.
So LangChain's conversation chain tackles this problem head-on. Now, it's not magic, it's just a really clever trick. What it does is it takes your entire chat history and automatically feeds it back into the prompt with every new message. So that stateless model suddenly has all the context it needs to have a real, stateful conversation.
And the process is actually beautiful in its simplicity. First, the chain grabs all the past messages. Second, it just sticks that history right into the new prompt. And third, it sends that whole package, the history plus your new question, over to the LLM. And just like that, the model can respond like it actually knows who you are.
Now here's where it gets really cool. LangChain doesn't just have one type of memory. It gives you a whole toolkit with different tools for different jobs. Let's take a quick tour of the big ones.
First up, we have conversation buffer memory. The easiest way to think about this is as a perfect word-for-word transcript of your entire chat. It remembers literally everything.
So with this method, you can see every single line from both you and the AI is stored exactly as it happened. It's a full chronological log. It's simple, it's direct, and for short conversations, it's incredibly powerful. But, and this is a big but, here's the trade-off. The upside is you get perfect, complete context. The downside, it uses up a ton of tokens. And as the conversation gets longer, that prompt gets bigger and bigger until you eventually smash right into the LLM's context limit. So it's great for a sprint, but it's not going to work for a marathon.
So to solve that token problem, we've got tool number 2, conversation buffer window memory. I like to think of this one as a sticky note because it only remembers the last few things you talked about.
So here, we've set the window size to just 2 exchanges. The model remembers the recent chat about researching LLMs, but it has completely forgotten that the user's name is James. It's this sliding window of memory, and it's perfect for when only the immediate past is what really matters.
Okay, but what if you need to remember important details from way back at the beginning of a long chat without storing every single word? Well, for that, meet conversation summary memory. I call this the meeting minutes, and it is super clever.
So, instead of keeping that huge, full transcript, this memory type actually uses another LLM to create a running summary of the conversation as it goes. You can see how the key details, the name, James, the topic of LLMs, are all still there, but they're packed into a much smaller, token-efficient summary.
The massive win here is that you can have incredibly long conversations while keeping your token use way down. The catch, though, is that you might lose some of the little details or nuance in the summary. The quality of your AI's memory is now totally dependent on the quality of the AI doing the summarizing.
And that brings us to the hybrid approach, conversation summary buffer memory. This is kind of the power user option that gives you the best of both worlds. It keeps a running summary of the whole conversation for long-term context, but it also keeps the last few raw messages in a buffer for perfect short-term recall.
So, we've got all these tools in our toolkit. How in the world do you choose the right one for your project? Well, it really all comes down to one fundamental trade-off.
And this is it. You have to ask yourself, do I need perfect word-for-word memory of everything that's been said? Or is it way more important for me to manage my costs and make sure my bot can handle super long chats? Your answer to that question points you to the right memory type.
This chart just makes that trade-off crystal clear. Just look at the token usage over time. The buffer memory just shoots up, and it becomes totally unsustainable really fast. Summary memory, on the other hand, stays nice and flat, totally manageable for the long haul.
So here's your cheat sheet. Use Buffer for short chats where every detail matters. Use Window for apps where only the last couple of messages are relevant. Go with Summary for those epic marathon-length conversations. And use Summary Buffer when you've got a complex dialogue that needs both the long-term gist and perfect recall of what was just said. Okay, one final but super important idea. By default, all of this memory we've talked about, it's temporary. It vanishes as soon as the session ends. But what if you want your user to be able to pick up a conversation right where they left off, maybe days later?
For any real-world app, you need what's called persistence. This just means saving the chat history to a database or some other external storage. LangChain makes this possible, so you can load a user's entire history when they come back. This is what transforms your chatbot from just a tool into a real, personalized companion.
And that leaves us with a pretty interesting question to chew on. We spent all this time trying to figure out how to make AIs remember. But as these things get more and more powerful, maybe the bigger question isn't what they should remember, but what we should design them to forget. Thanks for watching.